Again, good morning. We will continue with our second topic in statistics and probability. But before we go on with our second topic, let us first look at the written output that you were sent to answer. We were given a table which showed the number of goals scored by the Team Pinoy in the 20 games of the season. First, you were asked to construct a discrete probability distribution. Second, you were asked for the probability that if a random game is chosen, that the team scored 2 goals in that game. Third, you were asked for the probability that the team did not score at all. And fourth, you were asked to prove the properties. So let us look at the discrete probability distribution. We said that the discrete probability distribution would have the random variable, which in this case is the number of goals scored by the Team Pinoy, and the probability of that goals being scored by the Team Pinoy. So notice that the number of games, if the goal is 0, is 5. Again, if we're going to get the sum of all the games, then it will be 20. So the probability of getting no score at all would be 5 over 20, which is the same as 1/4. Second, you were asked to find the probability that the team scored only 1 goal in 7 games, so that would be 7 over 20. Third, you were asked for the probability that the team had 2 goals in 3 games, so that would be 3 over 20. The same with 3 goals, which is 3 over 20. And 4 goals, they only scored 4 goals in 1 game, so that would be 1 over 20. The same with 5. They scored 5 goals in only 1 game, so that would be 1 over 20. Second, you were asked for the probability if the random game is chosen, then the team scored 2 goals in that game. So looking at the table, the question is, what is the probability that the team scored 2 goals? So notice in our table that the probability that the team scored 2 goals is 3 over 20. Third, you were asked for the probability that the team did not score at all. Going back to our table, we're going to notice that the team did not score at all, that there were no score, was in 5 games, so that would be 5 over 20, which is the same as 1/4. And lastly, you were asked to prove the properties. Non-negative, we have noticed that the probabilities of all this random variable is greater than 0 but less than 1. And to prove the norming properties, we added all the probability, and adding all the probability, we were able to get 1. So let us now continue with our second lesson, the mean, variance, and standard deviation of a discrete random variable. So when we talk about the mean of a discrete random variable, we are also referring to the average, which can also be called expected value of the random variable x. So it is a weighted average of all the values that the random variable x have. The discrete random variable x assumes values or outcomes in every trial of an experiment with the corresponding probabilities. So again, the expected value of the random variable x is the average of the outcomes that is likely to be obtained if the trials were repeated over and over again. So let us look at the first example. Researchers surveyed the household in a small town. The random variable x represents the number of college graduates in the household. The probability distribution table for the random variable x is shown below. Okay, so we're going to notice that the random variable x represents the number of college graduates in the household of the small town. So the probability that there were no college graduate was 0.25. The probability that there is 1 graduate in a family was 0.5. And the probability that there were 2 graduates in a family was again 0.25. So to find for that expected value, we say all we needed to do was multiply the random variable with the probabilities because it is the weighted average. So we now multiply 0 and the probability of 0, plus we add the product of the random variable 1 with the probability and the product of the random variable 2 with its probability. So note that 0 is multiplied by 0.25, which is the probability that there is no college graduate. We add it up to 1 times 0.50 because it's the probability of having 1 graduate in a family, and add it up again with 2 times the probability that there were 2 graduates in a family. We add them all up. The answer was 1. Therefore, the expected value is 1. And the conclusion that we can make is the average number of college graduates in the household of the small town is 1. Let's look at another example. A security guard recorded the number of people entering the bank every hour. During one working day, the random variable x represents the number of people who entered the bank. The probability distribution is given. So let us look at the problem again. So we let x be the random variable which represents the number of people who entered the bank. You're going to notice that if x is the number of people who entered the bank, then the probability that there was no people entering a bank at a certain time is again 0. The probability that there was 1 person who entered the bank is 0.1, and 2 is 0.2, 3 is 0.4, 4 is 0.2, and 5 is 0.1. Again, x is the number of people who entered the bank. The probability are given as 0, 0.1, 0.2, 0.4, 0.2, and 0.1. To get the expected value, we only add the sum. We get the sum of all the product of the random variable with its probability. So we add everything up, and substituting, we get 3. The conclusion that we can now make is there were 3 persons. The average persons entering the bank in an hour is therefore 3. Okay, let us now look at the standard deviation and the variance. Deviation just means how far from the normal standard deviation. And the standard deviation is measure of how spread out the numbers. How far away are the values that you have? When you say spread of the numbers, how far away are the numbers from each other? How far away are the values of the numbers from each other? We will use the symbol, the Greek symbol sigma, to represent our standard deviation. And the formula is simply the square root of the variance. So our problem now is how we will get the variance. To get the variance, this is now the average of the square difference from the mean. So to calculate, you are given the following steps. First, you work out the mean or get the mean. Second, for each number, subtract the mean from each number, and then you square the result. Third, we work out the average of those square differences. Okay, let's look at our first example. Our first example is, you are asked to determine the variance and the standard deviation of the following probability distribution. So x, our random variable, has the values of 0, 1, 2, 3, and 4. And the probabilities are also given as 0.1, 0.2, 0.3, 0.3, and 0.1. Again, notice that according to the norming property, the sum of all the probabilities will now be equal to 1. Okay, first, we have to get the variance before we get the standard deviation. So first we find the expected value, and then we subtract the value from each outcome, squared each difference, and then we multiply the difference by the corresponding probability, and the sum of all the figures obtained in step 3 will now be our variance. Okay, this is now our solution. Notice in our first column, we have the random variables, which are 0, 1, 2, 3, and 4. On the second column, we have their probabilities. On the third column, we multiply the random variable with its probability. That's why 0 times 0.1 is 0. I am referring to the third column. Again, I am now referring to the third column wherein we multiply the random variable x with its probability. So 0 times 0.1 is 0. If the random variable is 1, we multiply it by 0.2, we get 0.2. If the random variable is 2, we multiply it by its probability of 0.3, we get 0.6. If the random variable is 3, we multiply it with its probability of 0.3 and we get 0.9. Fourth, if the random variable is 4, then we multiply it with its probability, which is 0.1, we get 0.4. So in the third column, to get the third column, we only get the product of the random variable and its probability. Why are we multiplying the two? Because if we add all of them, then we are able to get the expected value or the mean. First, remember, the first thing that we need to do is to find the mean. So again, to find the mean, we multiply all the random variable with its probability and then we add everything. The sum of the product of x, of the random variable x and its probability px is now what we call 2.1. So we got 2.1 by adding 0, 0.2, 0.6, 0.9, and 0.4 to get 2.1. 2.1 now represents our mean or our expected value. Why do we need the expected value? Because we need to subtract it from each random variable. In the fourth column, we will subtract the mean or the expected value of 2.1 from the random variable. So from the first column, 0 minus the expected value of 2.1 is negative 2.1. Second, 1 minus 2.1 is negative 1.1. Third, if the random variable is 2, we subtract 2.1, we get negative 0.1. If the random variable is 3, then we have 3 minus 2.1 is 0.9. And 4, if the random variable is 4, then we subtract 2.1, we get 1.9. In the fifth column, we now square the fourth column. So the square of negative 2.1 times negative 2.1 is 4.41. 1.21 is the square of negative 1.1 times negative 1.1 is positive 1.21. We square 0.1, we get 0.01. We square 0.9, we get 0.81. We square 1.9, we get 3.61. So these are the square of this. And then we simply multiply this 4.1 by its probability 0.1. Again, the last column is we multiply the fifth column with the second column or its probability. So 4.41 times 0.1 is equal to 0.441. 1.21 times 0.2 will give you 0.242. 0.01 times 0.3 will give you 0.003. 0.81 times 0.3 will give you 0.43. And lastly, 3.61 times 0.1 will give you 0.361. Adding all of the last column, we get 1.21. Again, where did I get 1.21? I got 1.21 by adding the last column. I added all of this to get 1.21. How did I get this? I multiplied this one with the probability. Therefore, I get this. And I add all of this to get 1.21. What is now 1.29? 1.29 is what we call our variance. And the square root of our variance will now be 1.14, which is our standard deviation. So again, 1.29 is our variance. How did I get 1.29? I added all of this. How did I get this? I multiplied the square with the probability. The probability with the square with the probability, the square with the probability to end up with 2.41. I add everything, I get 1.29. 1.29 is now our variance, and the square root of our variance is now our standard deviation. Let us look at the second example. You're given the discrete random variable x as the following probability distribution. So random variables are 0, 1, 2, 3, 4. Probabilities for 0 is 0.12. Probability for 1 is 0.25. Probability for 2 is 0.18. Probability of 3 is 0.35. And the probability for 4 is 0.10. You are again to find the variance and the standard deviation. So in the first column, we will see our random variable. On the second column, we are going to see our probabilities. On the third column, we multiply the random variable with its probability. So 0 times 0.12 is 0. 1 times 0.25 is 0.25. 2 times 0.18 is 0.36. 3 times 0.35 is 1.01. 4 times 0.1 is 0.4. We add everything up, we get 2.06. This is now our mean or our expected value. So from the random variable 0, we subtract 0.06. 0.06 is again our expected value or our mean. So 0.0 minus 0.06 is equal to negative 2.06. 1 minus 2.06 is negative 1.06. 2 minus 2.06 is negative 0.06. 3 minus 2.06 is 0.94. And 4 minus 2.06 is 1.94. Okay with this? Okay? So we will repeat. First is a random variable. Second is our probability. The third column is the product of the two. We add everything up. we get the mean or the expected value. This expected value or mean, we subtract from here. So 0 minus 2.06 is negative 2.06. 1 minus 2.06 is negative 1.06. Okay. And then we square this one. Negative 2.06 square is 4.24. 1.06 square is 1.112. Sorry, 1.12. 0.06 square is 0.0036. 0.94 square is 0.88. 1.94 square is 3.76. The square of this, we multiply with the probability. We multiply 4.24 by the probability 0.12. Therefore, I get 0.509. 1.12 multiplied by the probability 0.25 is 0.280. 0.0036 multiplied by the probability 0.18 will give me 0.0006. 0.88 multiplied by the probability 0.35 will give me 0.308. And 3.76 multiplied by 0.1 will give me 0.376. I add everything, I get 1.47. This is now my variance. And the square root of my variance is my standard deviation. So, let us repeat again. The first column is my random variable. The second column is my probability from here. My third column is the product of the two. 0 times 0.12 is 0. And then, from 0, I add all of this. I get the mean or the expected value. This expected value, we subtract from the random variable. So 1 minus 2.06 is negative 1.06. Okay. The result, the answer from here is to be squared. We now squared 2.06. I square, so I get 4.24. And then this 4.24, I multiply by the probability 0.12 will give me 0.509. Adding everything up, I get my 1.47, which is my variance. And the square root of the variance 1.47 is 1.22, which is now our standard deviation. So for your second written output, you are asked to solve these problems. The number of seen in an ER in any given is a random variable represented by X. So X would be the number of patients seen in the ER. You're given the probability distribution, and you are to find expected number of patients entering the ER in every hour. Number 2, a study aims to study the correlation between having a tattoo and cases of clinical depression. In one group of 12 people in the same age bracket, 7 have 1 tattoo, 3 have 2 tattoos, and the rest have 3 tattoos. If a person is randomly picked from this group and evaluated for depression, what is the expected number of tattoos that the person will have? And last, you are to find the mean, the variance, and the standard deviation of the following probability distribution. Again, you are to send your answers in my webmail, victor.carmencita@ess.edu.ph. Thank you. You are given 20 minutes to finish the job. Good luck, guys.